Hello everybody, and once again welcome to Pankaj's Echelon tutorials. In this today's session we are going to deal with the IGCSE curriculum as usual. Okay, so the curriculum for today's session is IGCSE, right? And the level is the ninth grade level, and the subject and the topic is of course maths and number system. Okay, but today we are going to do in number system something called rational and irrational numbers. Okay, this is something we are going to study, rational and irrational numbers. Okay, so let us get started. And to get started, we should first deal with some revision part of this numbers. Okay, so in the previous sessions or the previous videos, I have already discussed with you people about natural numbers, that is denoted by n. So natural number is a set of numbers which includes numbers like 1, 2, 3, 4, 5, 6, 7, 8, and it goes on up to infinity, and this infinity end is a positive infinity. Infinity is a very large number. Okay, so the last number, you cannot have a ultimate last number of a natural number. Okay, but it is in general it can be called as a positive infinity. Whole number is another set of numbers where it starts with a zero, and then you have a set of all natural numbers attached to it, that is 1, 2, 3, 4, 5, 6 up to plus infinity. So whole numbers is nothing but natural number only, but zero is included in that. So here you can make one conclusion that natural number is a subset of whole number, isn't it? Natural number is included in whole numbers, right? Fine. Integers. The next set of numbers is called integers. It is denoted by I. Many books they mention they denote integers by Z. Okay, so one and the same thing. So I is integers, and integers will include a zero and all the positive numbers 1, 2, 3, 4 up to positive infinity, and all these numbers which are known as negative counting numbers, that is -1, -2, -3, -4, blah 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 up to minus infinity. Okay, so integers is something which includes whole numbers, that is 0, 1, 2, 3, 4, and this part of the number you can call it as negative natural numbers. Okay, these are negative natural numbers. So here I can make a statement that this integers is nothing but it is a union of whole numbers. It will contain all whole numbers, that is 0, 1, 2, 3, 4, and it will contain also negative natural numbers. Negative natural numbers can be written as n raised to minus. Okay, negative natural numbers are natural numbers with a negative sign before those numbers. Okay, simple as that. So those are integers, and of course you have a zero also in that. Okay, and also a zero. So integers are nothing but a combination of zero, or rather when I mentioned whole number, there's no question of putting this zero now. Okay, because zero is included in the whole number. Okay, so need not put this. Fine. So that is okay, right? So integers is nothing but a combination of whole numbers which consist of zero and the natural numbers, and there's also negative natural numbers included in the integers. Is that okay? Fine. So this is what I have put into revision. Now this is what you have studied in the earlier classes up to a standard, right? Now we are going to start with a new concept called rational number, which is denoted by Q, and irrational number, which is denoted by a Q bar. Now what are rational numbers and irrational numbers? Basically, if you see, rational numbers and irrational numbers are obtained from this above numbers only, that is natural numbers, whole numbers, integers only. See, integers contains somehow whole numbers, and whole numbers contain somehow natural numbers, isn't it? So set of integers will be containing directly or indirectly all the natural numbers also, isn't it? Now let us come to rational numbers. Now what are the rational numbers? Now many a time, students, they don't understand what is rational number, or if they understand, they understand only a part of a definition of rational numbers. If the numbers are in a twisted form, okay, in some other form, then they are not able to confidently say whether it is a rational number or not. So what are rational numbers? Okay, for this I have put an answer in so many forms. Okay, so there are so many definitions you can say for rational number, right? So what are rational numbers? So number first point is this one. This is the first point. What is it? All integers are rational numbers. Okay. So if you can say that a particular number is an integer, then you close your eyes and you can say that it is a rational number also. What I mean to say is all integers are rational numbers, right? So minus 1, is it an integer? Yes, it is an integer. So it is also a rational number. 0, it is an integer. Yes, it is an integer. So it is also a rational number. Okay. 25 is an integer. So it is also a rational number. Right. So all integers are rational numbers. So whenever you come across any integer, you can blindly say that they are rational numbers as well. Second point is this one. Natural numbers and whole numbers are also rational numbers. Okay, natural numbers and whole numbers, they are also rational numbers. So all natural numbers and whole numbers are also rational numbers. So this statement is also correct. All natural numbers and whole numbers are rational numbers. Okay, so name any natural number, name any whole number, they have to be rational number. So whole number mein 0 is a whole number, so it is a rational number. Yes, it is a rational number. 25, is it a whole number? Yes, it is a rational number. Yes. 9 is a natural number, so is it a rational number? Yes, 9 is a natural number, so it has to be rational also. Okay, so all natural and whole numbers are also rational numbers. Okay, now coming to a slightly trickier part, certain fractions are rational numbers. Now here I have not mentioned, this is the third point. Certain fractions are rational numbers. What I mean to say is certain means not all fractions are rational number. Okay, so there are certain fractions which are rational number. What are the certain fractions? The certain fractions must be of the form p by q, where p and q are integers, and the denominator wala integer jo hai, that is q, it should never ever be equal to 0. It should be not equal to 0. It should not be 0. Okay, so such numbers, if you want to take as an example, so suppose minus 25 is an integer. Yes, it is an integer. And then 5 is an integer. Yes, or you can say 15 is an integer. Yes, it is an integer. Moreover, this 15 is not equal to 0. So this is a rational. Okay. 22 upon 7. Now 22 upon 7, many a times students, they think that it is an irrational number. Okay, because 22 upon 7 is a value which is used instead of pi. Okay, when you do questions on area of a circle, you use pi r square. Okay, or when you want to find out the volume of a sphere, you use the formula 4 upon 3 pi r cube. So in all these formulas, that pi, is many a times taken as 22 upon 7, and we all know that pi is an irrational number, right? But then 22 upon 7 is not an irrational number, it is a rational number. Okay, why? Because 22 is an integer, so p is an integer. 7 is an integer, so q is an integer. So it is satisfying this condition, p and q are integers. Moreover, this integer in the denominator, q, is not equal to 0. Yeah, this 7 is not equal to 0. So it is satisfying all the conditions of this definition of rational number. So why we should call it a irrational number? So this is not an irrational number. 22 upon 7 is a rational number. Got it? Fine. Now, fractions which are non-terminating and non-recurring are not rational numbers. Okay, so all fractions, certain fractions are rational number, I told you. Then question comes to your mind that which are the fractions which are not rational numbers. So immediately I have given the answer in the fourth point. The fractions which are non-terminating and non-recurring are not rationals. Okay, so for example, if you take 22 upon 7, okay, 22 upon 7 is a rational number. Okay, why? Because here also we told you it is a rational number, and 22 upon 7 is coming in the category of non-terminating and recurring. Okay, it comes in the category of non-terminating and recurring, and non-terminating and recurring are always rational numbers, right? Which are not rational numbers? Non-terminating and non-recurring. Okay, so which number can come in this category? Non-terminating and non-recurring. So any fraction which, if you try to work out, and the answer, the portion that you get is not a recurring decimal, okay, then that number will always be irrational number, or you can say that will not be a rational number. For example, root 2. Now root 2, everybody knows the value is 1.412 dot dot dot. Now here this root 2 ka value is 1.412 dot dot dot. Now this 1.412 is telling you that it is a non-terminating and non-recurring fraction. So this non-terminating and non-recurring fractions are not rational numbers. So root 2 is not a rational number. Similarly, root 3, 1.732 dot 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 dot. When I say dot 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 dot, that means there are so many numbers which are following, and there is no recurring pattern that you are getting. Okay, no pattern will be repeated after the decimal point. So this comes under the category of non-terminating, non-recurring. So such numbers are not rational. So root 2, root 3, root 5, all these are not rational numbers. Okay. So fractions which are non-terminating and non-recurring are not rational. Then immediately the question arises that, okay, if a fraction is non-terminating and non-recurring and it is not rational, you said that it is not rational, fine. Then what it can be called? Immediately the answer is such fractions can be called as irrational number. So if you go for the definition of irrational number, you will have this. A fraction which is non-terminating and non-recurring are irrational number. Or I'll write here only so that there's no confusion. Fractions which are non-terminating and non-recurring are not rational numbers, but irrational numbers. Okay, they are known as irrational numbers. Irrational numbers are denoted by Q bar. Rational numbers are denoted by Q. Irrational numbers are denoted by Q bar. So I have told you, explained you what are rational numbers, what are irrational numbers. Okay. Now let us see this division that I have done. I have tried to work out 22 upon 7. Can you see this 22 upon 7? I told you that 22 upon 7 is a rational number. Now I am justifying my statement. Suppose 22 upon 7, if you go for division, 22 divided by 7. So 22 divided by 7 will start with 3. So 7 3s are 21. Remainder is 1. Then you will put a decimal point and bring down 0. Okay. Then 7 into 1 will be 7. You'll get 3 as remainder. You'll take 0 again. Then 7 into 4 is 28. You'll get 2 as remainder. You'll bring down 0 again. That way, if you keep on going, along this line, you are never ever going to get a 0 as a remainder. So such a division, such a fraction is non-terminating. Why non-terminating? Because no 0 remainder. Okay, you're not getting remainder as 0. Non-terminating. But if you see this particular pattern in the quotient, you will get 3.142857. Then you will get again 14252857. So this 142857 is repeated. This group of digits, is repeated. So this is coming under recurring fraction. So I can write this as recurring fraction. Okay. So recurring means uh, uh, a number of digits after the decimal is repeated. So combine, you can say this is NTR, non-terminating recurring. Okay. So 22 upon 7 is a non-terminating recurring fraction. And non-terminating recurring fractions are coming in the category of rational numbers. So they are rational. Okay. And that is why I call this 22 upon 7 as a rational number. Even otherwise, the definition of rational number is any number of the form p upon q, where p and q are integers and q not equal to 0. This definition is also satisfied over here. 22 is integer, 7 is integer. Moreover, this 7 is not equal to 0. So that definition wise also it is rational number. And if you try to divide and see what is the quotient, you are getting a non-terminating recurring decimal, okay, or fraction, non-terminating recurring fraction. And non-terminating recurring fractions are rational numbers. Is that clear? So 22 upon 7 is a rational approximate of pi. So pi ka value, it is actually 3.14159 dot 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 dot. So pi is an irrational number, okay, because this dot 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 represents that it is not recurring, okay. And whenever it is recurring, you will always put a bar on top of the recurring digits, okay. Here I have not put bar on any set of digits after the decimal point, so this is indicating that it is non-recurring, okay. So pi ka value is 3.141592 dot dot dot, means this is non-terminating and non-recurring, NTNR. So NTNR are numbers, NTNR numbers or NTNR fractions. NTNR means non-terminating, non-recurring. Such fractions are nothing but irrational numbers. So pi is an irrational number. But 22 upon 7, which we use as a substitute for y, is actually a rational number. Okay, so you can say that 22 upon 7 is a rational approximate of pi, which is irrational. Is that clear? Okay. Now coming down to more definitions. Fractions which are terminating are rational numbers. Now any fraction which will terminate is known as a terminating fraction. Now what is the meaning of terminating? Terminating का मतलब होता है, the meaning of terminating is you should get a remainder as 0 sooner or later. Okay. Whenever you get a remainder as 0, we say that fraction is terminating. So any fraction which is terminating is a rational number. So many definitions I am giving you for rational number. Okay. So this is for you to identify whether a number is rational or not, or for you to justify whether the number is rational or not. Okay, I am giving you all these details, right? No book will give you all these definitions separately. Okay, this explanation I am giving you because it is going to help you in deciding which number is rational, which is not rational, and if it is a rational or irrational, what is the reason that it is called as rational or irrational. So all this you will be able to answer these such questions when you study in this way. Okay. So fractions which are terminating are always rational numbers. For example, 24 upon 25. Now this is a fraction. And this fraction 24 upon 25, if you try to work out, okay, you will get a remainder as 0. Always you will get a remainder as 0. Now here there is a trick which I will discuss in some other video, that why confidently I am saying that 24 upon 25 is a terminating fraction. Even this 7 upon 8 is a fraction which is terminating fraction. 49 upon 10 is also a terminating fraction. Okay. Rather this 14 upon 10 is not a terminating fraction. 17 upon 50 is not a terminating fraction. Okay. This 49 upon 10 is not a part of this. Okay. This is something else, right? ये इसका part है, right? So this one is there, 17 upon 50. So 17 upon 50, 7 upon 8, 24 upon 25. These three circle number are all terminating fractions. Okay. So all terminating fractions are rational numbers. So these will come in the category of rational number. Okay. Even otherwise, if you see, the rational number ka definition is sufficient to tell you that these are rational numbers. P upon Q, Q not equal to 0. Done. Now, fractions which are non-terminating and recurring are rational numbers. Okay, so these are all. This is also another way of identifying whether a number is rational or not. So, if a fraction is non-terminating but it is recurring, then we say that it is a rational number. Now, for example, 7 upon 30. If you do this 7 upon 30, okay. No, sorry. Again, 7 upon 30. I should do something about this. Now, this is a part of that division. Okay, which division? 22 upon 7. Right? The part of that division. Fine. So fractions which are non-terminating and recurring, the examples are this: 2 upon 3, 5 upon 11, 5 upon 6, 13 upon 10. Now if you go for dividing, if you go for division and try to find out the portion in the decimal form, these are fractional form. If you try to find out the decimal form of corresponding to this fraction, the answers that you will get will be terminating decimals. They are terminating decimals. Okay, means what I want to say is you will get the remainder as 0. Remainder will be 0. Okay, so terminating decimals are rational numbers, right? Fractions that are non-terminating and recurring are rational numbers. Terminating decimals are rational numbers. The example of terminating decimals are rational is this. Now these numbers, can you see 2 upon 3, 5 upon 11, 5 upon 6? These numbers are terminating decimals. Why they are known as terminating decimals? Because when you work out, the remainder will not be 0 because they are non-terminating, and the answers will be like 0.25, 1.5, 3.52. These are the numbers, okay? And these numbers also, if you see, you will get, you will see that they are terminating decimals are, okay, sorry, I'm getting a little bit of this thing. I'll repeat from here. Fractions which are non-terminating and recurring are rational numbers. Okay, an example I have given here. Okay, these are the examples: 2 upon 3, 5 upon 11. Now these are the examples of fractions which are non-terminating. Now when I say non-terminating, means remainder will not be 0, will uh, not be 0. Okay, remainder will not be 0. Okay, so, but the quotient will be having a recurring digit. Okay, so let us try one. Fraction which are non-terminating and recurring. So let us try this 2 upon 3. So if you try to divide this way, 2 upon 3. Okay, so 2 divided by 3. So first I'll get 0 point and I'll put a 0 over here. Then 3 into 7, no, 6. 6 threes are 18. Okay, so I'll get 18 over here and I'll get a 2 over here. Again, I'll take a 0. Again, I'll get 20 over here. So same 6 I'll have to put here. Okay, 6 threes are 18. Again, I'll get a 2. Again, I'll get a 0 over here. So can you see this answer? You will never ever get a 0 remainder. Okay, 0 remainder you will not get. That is why I told you that it is non-terminating fraction. Okay, non-terminating. But if you see in this quotient, you will see that this 6, is getting repeated. It is recurring. So 0.6 bar is a recurring fraction. Okay. So this example 2 upon 3 is an example of non-terminating because you never get a 0 as a remainder, and recurring because in the quotient you get a number which is repeated. Okay. And that number in this case is 6. And all these other numbers also, if you try to go for division, you will get the same thing. They will be non-terminating and they will be recurring. Okay. So non-terminating but recurring will come under rational numbers. Okay. Terminating decimals are rational numbers. Now any number, any fraction which is terminating will be always a rational number. Okay. And if a number is terminating, if a fraction is terminating, then the quotient will always have end to it. Okay, so it will not be, and it will not have repeated things. Okay, so the answer will be like 0.525, 1.5, 3.52. So such decimal numbers where you won't have any bar. Okay, but can you see there's no dot 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 also? Okay, so when there's no dot 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 means there is the remainder is has come to 0. Okay, so that these are known as terminating decimals. So these terminating decimals can be identified by two things. One is after the decimal the digits will not be having dot 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 dot, number one. Second, after the decimal you will not find any bar on top of any digit. Okay, so they are not recurring. So such decimals are known as terminating decimal. For example, 5 divided by 2. Everybody knows 5 divided by 2 is 2.5. Okay. Now here there's no bar on top of 5. Okay. And after 5 there's no dot 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 also. So this is a terminating decimal. So it is a rational number. Even otherwise 5 upon 2 by the definition of rational number, p upon q, q not equal to 0. It is a rational number. So I hope you are getting it, the concept you are getting it clear. Okay, what are rational numbers, how to identify them, and how to differentiate one from other. Okay, now coming to next point, that is this one. Recurring decimals are rational numbers. Okay, so whenever a decimal is whenever a number is in the decimal form and something is indicating that it is recurring decimal. Now how you will come to know whether a decimal number is recurring? After the decimal point you will see a digit or a group of digit which is continuously repeated. Okay, so in 0.6 bar this 6 is repeated continuously. Okay, so you put a bar over 6. In 0.45 bar Okay, for bar is on both 45. Okay, so the 45, the group of 2 digit 45 will be repeated again and again. So it will be 0.45454545 that way. This 0.83 and the bar is only on 3. So this is the number which can be written as 0.833333. So 0.8 is there, but 333 is getting repeated. Okay, so this is also a recurring decimal. Then 0.118, but the bar is only on top of 18. So this number means 0.1, 18, 18, 18, 18. 18 will go on repeating. Okay, so such numbers are recurring decimals. They are also coming in the category of rational numbers. Now, number with a radical sign, like say square root of some a, such that a is not a perfect square, okay, or a perfect cube, then this is called a recurring number. This is called as recurring number. Okay. Now, suppose you have a number of the form root of a such that a is a non-perfect square. Okay, sorry, is not a perfect square. Okay, now this is something I have not written correctly. Number with a radical sign. Okay, and inside that radical sign, suppose you have a number a such that a is not a perfect square or not a perfect cube, then such numbers will be called as not recurring numbers, but they will be called as irrational numbers. So here I have to make this rectification. These are irrational numbers. Okay. For example, root 2, root 3, root 5, root 35. All these are numbers, or rather cube root of 28, cube root of 82. Okay. All these are numbers which are either square roots or cube root, and inside the square root of cube root, you will see if it's a square root, then inside there will not be a perfect square. If it is cube root, there will not be a perfect cube inside. Okay, such numbers will always be irrational number. Got it? But if a square root sign के अंदर if there is a perfect square or a cube root sign के अंदर if there is a perfect cube, then such numbers will be rational numbers. Okay, so this type of numbers, this is the example of irrational numbers. Okay, okay. The numbers which are non-terminating and non-recurring are irrational numbers. So root 2, root 5, root 3, if you try to work out the values of this root 2, root 3, root 5, you will find that they will be irrational numbers. Okay, you will never ever get a remainder as 0. So it is non-terminating, and you will never get a quotient which is recurring. So it is non-recurring. So it will be non-terminating, non-recurring. So irrational number. Okay, so these three will be irrational number, because you will get a non-terminating, non-recurring number. But root of 36, root of 64, root of 144, root of 36, this is a perfect square. This will work out to 6. This will work out to 8. This will work out to 12. And 6, 8 and 12 are nothing but natural numbers, and they are rational. So these are not irrational numbers, these are rational numbers. Root 36, root 64, root 144 are rational numbers. Okay. So here in this case, if you have root 36, root 144, then because these work out to a rational number, these are not irrational number, but these are rational numbers. Okay. These are of course irrational numbers. Is that clear? Chalo. Now let us make a summary of all this. What are irrational numbers? Okay. So now we have studied so many things about rational number. So let us see what is irrational number. Irrational numbers are denoted by Q bar. Now what are the points you should know? Numbers which are not rational are irrational. So any number which doesn't come in the category of rational number, they will be irrational. Fine. Second point, numbers which are not non-terminating and non-recurring. So I told you previously only in the definition, any fraction which is non-terminating and non-recurring will be treated as an irrational number. Okay, such numbers you will not get in the fraction form, but you can write it in the quotient form. So in the quotient form you will get a number like 3.14128 dot dot dot. So whenever you see dot dot dot, that means it is non-recurring. Okay, so such numbers are irrational numbers. Then any number under a radical sign which are not perfect square or perfect cube. So there will be a radical sign. This is square root sign, this is cube root sign. But inside a square root sign, if there is not a perfect square, okay, not perfect square. For example, 24 is not a perfect square. Not a perfect cube. For example, 28 is not a perfect cube. So such numbers which are placed under the radical sign and they are not perfect square or perfect cube, such numbers will be irrational numbers. So root 24, cube root of 28 are not rational numbers, they are irrational numbers. Okay. So root 2, root 3, root 6, this 3.14159 dot 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 2.718281 dot dot dot, all these are examples of irrational numbers. The pi number, the pi that we use, okay, that is 3.14, this is the irrational number. E ka value is 2.7821 dot dot dot, this is also irrational number. Okay. Now putting all this together, let us see what happens. Now when you try to put all this together, real numbers is something which can be classified into two categories, main category, that is rational and irrational number. So when you compile everything and put it in a one bag, okay, suppose you have a lot of rational numbers, you have a lot of irrational numbers, you put them in a bag, so that bag will be called as a real number bag. So what are real numbers? Real numbers are all numbers which are rational as well as irrational, or you can say real number which is denoted by R. Okay, real number is denoted by R, is a union of rational number and irrational number. Okay, so it is a combination of rational as well as irrational number. So you can indicate this as a set diagram. Suppose this big box is real numbers and it is divided into two partition. Okay, one partition may you have Q, that is rational number, other partition may you have irrational number. Okay, so you are carrying all rational number in two partitions, rational and irrational. Okay, so this will help you in understanding that rational numbers are real numbers, irrational numbers are real numbers. Okay, so combination of both real number is equal to rational number plus irrational number, that way also you can write. Okay, now second point is rational numbers are all essentially divided into what? Now these rational numbers, they will be divided into natural numbers, whole numbers. I told you in the beginning only, natural number, whole number, integers, they all will make up rational number only. And there are certain fractions also which come under rational number category. But which fraction? Terminating fraction and non-terminating fraction but recurring. Okay. So all this will come in the rational number category. Now Q bar, this is irrational number. So what is this irrational number? Irrational number will be okay. Now this is something what I have written. Irrational number is natural number, union whole number, union integer, union terminating fractions, union non-terminating rational numbers. So this is not actually rational number, irrational number. This is rational number. I should not put a bar on top of it. Okay. So rational numbers will be what? All natural numbers are rational numbers. Whole numbers are natural numbers. Integers are rational number. Terminating fractions are rational number. And non-terminating recurring numbers are also rational number. Okay. So that is what I have written in this point. Fine. Now why I have written this way? Because integers contain natural numbers and whole numbers. So if it is an integer, then it is a natural number also and whole number also. So therefore, natural number is a set of integer, subset of integer. Whole number is also a subset of integer, and integer is a subset of rational number. So when integer is a subset of rational number, then whole number and natural number will also be subset of rational number. That is this point. Now, all natural number, whole number and integers are rational numbers. Okay. All natural number, whole number and integers are rational numbers. Terminating fractions are also rational numbers, and non-terminating fractions are non-terminating recurring fractions are also rational numbers. So from here you come to know there are so many numbers you can identify. If they come in any one of this category, you can say it is a rational number. And last but not the least, only NTNR. NTNR means non-terminating, non-recurring. Non-terminating, non-recurring numbers are only irrational numbers. Okay. So irrational numbers will be the numbers which are non-terminating and non-recurring. Okay. But remember, only don't check whether it is non-terminating or non-recurring. There are other ways also for finding out whether a number is irrational. As I told you, if under a square root sign you have a non-perfect square, or under a cube root sign if you have a non-perfect cube, okay, NPC means non-perfect cube, NPS means non-perfect square, then such numbers are also irrational numbers. Okay, so this way also you can identify. And suppose in the decimal form, suppose you have 2.513 dot 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 dot. Suppose you find this dot 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 after the numbers in the end, then they also indicate that they are irrational numbers. Okay, so this way you can immediately identify which are rational, which are irrational. Now set diagram. Question number, now set diagram is first I want you to understand this set diagram. This big box is a real number box. Real number box is having two partition. In one partition you have all rational number, in other you have irrational numbers. In rational number you have again three more pockets. Okay, the rational number ka under you have integer ka pocket. Inside integer pocket you have whole number pocket. Inside whole number pocket you have natural number pocket. Okay, so this is all pocket inside pocket, that way you can say, right? Or you can say a box inside a box. So suppose this is a box of say rational numbers, then inside this box, okay, if you will have a box of integers, and inside this integers you will have a box of whole number, okay, and inside this whole number you will have a box of natural number. Okay, so this is the order. The outer box is rational number. I'm sorry, it should be Q, not R. Okay, so the outermost box is representing your rational number Q. Inside the rational number box you have integer. Inside the integer box you have whole number box, and inside the whole number box you have natural number box. That is what I have shown here. Now try to understand this question. A, B, C, D, E, F, G are the numbers given over here. A is 8.4, B is 5/6, C is cube root of 16, D is minus 87, E is 0, F is 3 raised to 99, and G is root of 49. My question is, put the following numbers in the appropriate place in the box alongside. So these numbers you have to put it in the box. Okay. Now answer is already given here. I have shown you, but I'll explain you how it works. Now first let us pick up this 8.4. 8.4 is what? Looking at it, I can say it is a terminating fraction. Okay, because I cannot see any bar on top of the digit after the decimal point. Okay, so it is a terminating fraction. Now terminating fraction, I told you, they are all rational numbers. So I'll put it in rational number. So A I have put in this rational number box. Okay. B is 5/6. Now 5/6, why it is a rational number? I have put in rational number B again. Why? Because this there's a second definition of rational number. I told you P upon Q, where P and Q are integers and Q not equal to 0. So that definition is fitting this 5/6. So that is why I put it in a rational number box. Then C is cube root of 16. Now cube root of 16, if I work out, it is it will be a irrational number. Now I cannot go and work out and check it, but there's another way. As I told you, if it's a cube root ka sign, and inside if a number is not a perfect cube. Now 16 is not a perfect cube. 16 is a perfect square, but 16 is not a perfect cube. So this 16 is not a perfect cube, but it is put inside a cube root sign. Okay, so whenever inside a cube root sign you have a non-cubic number, non-perfect cube, then this will always be irrational number. Therefore C comes in irrational number category. So I have put C over here. Now coming to D, D is minus 87. Minus 87 is what? It is nothing but a natural number with a negative sign. So you can say negative natural number, and negative natural number is a part of an integer. Okay, so minus 87 I have put in this integer box, that is D. E, 0. 0 is again an integer. So E I have put it in. I could have put in integer also, and because 0 is also a whole number, so I have put it in the whole number box. E I have put it in the whole number box. Okay. Then F is 3 raised to 99. 3 raised to 99 is a huge number, a big positive number. So you can say it is a natural number. So 3 raised to 99, that is F, I have put in natural numbers. And root of 49, now root of 49, don't think that it is under a radical sign, so it will be irrational. No, root of 49 is inside the square root sign, but 49 is a perfect square. So when you have a perfect square inside a square root sign or a perfect cube inside a cube root sign, those numbers will be rational numbers. So 40 root 49, even otherwise this root 49 will work out to what? Will work out to 7. And 7 is a rational number. Okay, so that is why I put in the natural number category. So I hope this particular question is understood. And one more question before we wind up this session. Okay. Okay, there are many more questions. Okay, which are rational and which are irrational? Now 0 upon 5. Now one thing you should remember now, 0 upon any number, okay, will be equal to 0. In any fraction, if you have numerator as 0, that fraction will work out to 0. Okay. Another thing is any number divided by 0 will be equal to not defined. Okay. So any number which is in a fraction form but the denominator is 0, then it is not defined. Not defined means it will not, it is meaningless. Okay. So 0 upon 5 will be 0 and 0 is an integer. So 0 upon 5 will come in a rational number. 5 upon 1 is a rational number. Root 33, you can see square root sign and it is not perfect. Okay, 33 is not a perfect square. So this will come in the irrational category. Minus 55 upon 10, 55 and 10 both are integers. 10 is not a minus 55 and 10 both are integers. Moreover, 10 is not 0, not equal to 0. So by the definition, it will come in this category, rational numbers. Okay. Root 36 will ultimately work out to 6 and 6 is a rational number. So root 36 will come in this category. Okay, rational number. Yeah, so root 36 will come here. Then cube root of 27, again cube root of 27 will work out to 9, which will come in rational number. 0, 0 is an integer. So integers are rational number. So 0 is also a rational number. Pi, irrational number. E, irrational number. Fourth root of 25, fourth root of 25 is, this 25 is not a perfect, this thing, okay. So if you try to find out this fourth root of 25, okay, you will get an irrational number. So fourth root of 25 will come in this category, irrational number. 8.4, it's a terminating fraction, rational number, okay. 8.14 bar, recurring decimal, so rational number. 0.814 bar, again rational number because it is a recurring decimal. 0.0128 dot dot dot, irrational number. 9.1283 dot dot dot, irrational number. Got it? And last question, try to answer this in true or false form. Square root of a perfect square is irrational. Cube root of a perfect cube is irrational. Cube root of a perfect cube is rational. Square root of a perfect square is rational. Now this I have already mentioned in my discussion. Square root के अंदर अगर perfect square होगा तो it will work out to a rational number. So it will not be a irrational number. So this first वाला statement is false. This is false. Cube root के अंदर if you have a perfect cube, then it will work out to a rational number. Okay. So it cannot be irrational number. So this is also false. Now cube root के अंदर if you have a perfect cube, it will work out to a rational number. So it is a rational number. So this is true. And square root sign के अंदर if you have a perfect square, it will work out to a rational number, which is true. So this will also be true. Let me give you examples of this. A perfect square under a square root. So square root of 36. Now this is equal to 6. Now 6 is not irrational. 6 is rational. So this is false. Now let us take a cube root of 27. Okay. Now cube root of 27 is what? It is 3. 3 3s are 9, 3s are 27. And 3 is what? It is a rational number. And here it is written irrational. So this is also, this is 3. So this is also false. 6 is rational number, 3 is irrational number. But here it is written irrational. So that is why this is false. Now cube root of a perfect cube. Okay, so let us take cube root of 81. Now cube root of 81 is what, you know? Can you work out? 3 is a 9, 9 is a 20. No. Let us do this way. Cube root of 4 4 is 16, 4 is 64. Yeah. Cube root of 60. Sorry. Yeah. Cube root of 64. Okay. So this is cube root के अंदर a perfect cube. Now this 64 is a perfect cube. Okay, so this will be a rational number. So it is true. Now what will be that number? You know, 4, because 4 into 4 into 4. 4 fours are 16, 16 fours are 64. So 64 is a perfect cube, and perfect cube under a cube root sign is always a rational number. So this is true. Same way, square root of say 144. This will also be 12, and 12 is a rational number, so this is true. Okay, so first and second are false statement, third and fourth are true statement. Is that clear? So with this entire number system, what are rational number, what are irrational number, the concept I have explained you in a very nice way. Now you have to practice with some numbers, and you have to, you know, try more numbers, try to do some numericals. In the next video I'll get some numericals on this, and you should get a real thorough practice of all this thing. Then and only then you will be you know, understanding this basic mathematics at this level. Okay, so if you happen to like this video, please subscribe my channel. And that's all for today's session. See you in the next session later. Bye, take care all of you.